So we are going to look at simplifying radicals today. This may be new information to some extent. You've probably seen a radical or you know it as a square root. Does that word sound familiar? Okay, so radicals, we're going to specifically focus more on square roots. But as you move up into IM3 and hopefully beyond, they're known as radicals, or we talk about like cube roots or fourth roots, but again, we're specifically going to focus on square roots. Okay. So let's start with some basic ones. Perfect squares. Anyone know what a perfect square is? Or can you give me an example of a perfect square? Three squared?
X squared.
X squared? Okay, let's just deal with numbers first. Let's not deal with variables because we're going to get to variables in a second. Okay, so if I asked you what the square root of 16 was, could you tell me what the square root of 16 is, Annie? 4. Square root of 16 is 4. So what we're looking for is two numbers, or the same number that multiplies by itself. Those are known as perfect squares. So 4 times 4 gives me 16. Right? Okay. Now what if I didn't know that? You have two options. You have a calculator, and in your calculator you can type in the square root of 16, or we can simplify the square root of 16. So we're going to do what's known as a factor tree. Give me any two numbers that multiply to 16. 4 and 4. Okay. Now we're dealing with square roots, so we're going to look for pairs. Do you see a pair? I see a pair of 4s, right? So that pair is what your answer is, but it's only one of them, because 4 times 4 gives me 16. I want to know what number I would multiply by itself to give me 16. What would the square root of 1 be? 1? 1 times 1 is 1? Okay. What about the square root of 36? 6? Okay. So what if I didn't know that? I know that 9 times 4 is 36, right? Do you see any pairs? No? Okay. So I'm going to keep going. So I broke down 9 to 3 times 3. Are you okay with that? And I broke down 4 to 2 times 2. Do you see any pairs? I see a pair of 3s. And I see a pair of 2s. What's 3 times 2? Do you see how we're breaking that down? Because there's going to be some that are not perfect squares, and we're going to have to use a factor tree to break them down, because I'm not always going to ask for a decimal answer. I want an answer in simplest radical form, and we'll talk about that in a second. So let's do one last one for a perfect square. What is the square root of 9? 3. Okay, because 3 times 3 is 9. Understand where we went there? Okay, so if I give you the square root of 72, you're going to look at that and say, I don't know, right? I don't know if there's a number that multiplies by itself. Some of you are, I can see your brains working. Okay, 8 times 8 is 64, 9 times 9 is 81, so there's nothing in between, right? So this is where we have to do our factor tree. So we're going to break everything down. So give me two numbers that multiply to 72. 8 and 9? Okay. I don't see any pairs, so I'm going to keep going. Now, once you break down a number, so like I broke down 8 to 4 and 2, I'm not going to look at that 8 anymore. Here's where people will tend to get confused. So once you break it down, because 4 times 2 is 8, right? So it's still there, but I'm not going to worry about this 8. I broke down 9, so I'm not going to worry about that 9. What else did I break down that I shouldn't look at anymore? 4. Right? 4 broke down to 2 and 2. So the only thing I'm looking at are these bottom numbers. Do you see any pairs? You have a pair of 2s and a pair of 3s. What's different about this problem compared to like 36? Do you see something? There's an extra number. There's this extra 2, right? So we're going to deal with that in a second. So these pairs we're going to multiply together. 2 times 3 is 6. And then whatever's extra stays inside the radical. Okay, so we take our pairs and we multiply them together. And then whatever's extra stays inside. And watch how this works. So if I took my calculator, for instance, and I did the square root of 72, I get this super long decimal. Right? And I'm going to write this out because we're going to talk about rounding too. So 8.48528. I'm going to just stop there. Okay? Well, what if I also plug in 6 square root of 2? Where's my square root? What do you think my answer is going to be? Should be the same thing. Is it the same thing? Yeah. Okay, so this is known as simplest radical form. Simplest radical form. So if I ask you to write it in simplest radical form, I think I spelled that wrong, but that's okay. If I ask you to write it in simplest radical form, you're going to break down the square root, find your pairs and pull them out, and leave whatever's left over inside. Okay? Now I also may ask you to round. So let's talk about rounding. Oh, you nervous about rounding? No? Are you sure? Okay. So there's going to be 3 options. You're going to round to the 10ths place, the 100ths place, or the 1000th place. So before we actually round this number, let's figure out what that place value is. So if I want you to round to the 10ths, how many numbers after the decimal should I have? McKenna? Never mind. Annie? 1. So if you're rounding to the 10ths, there should only be 1 number after the decimal. What about the 100ths? 2. And the 1000ths? 3. Great. Now, do we remember how to round? So if I'm rounding to the 10ths, I know I only need 1 number, but I have to look at the number after it. What does that 8 tell you to do? Round it up to a 5. So this particular one would be 8.5. So if I said round the square root of 72 to the 10ths place, I know I need 1 decimal, so I look at the 1 after it. Anything above 5 rounds it up, giving me an 8.5. For the 100ths place, I need 2 decimals, so I'm going to look at the 3rd one. What does that 5 tell me to do to the 8? Round it up, so my answer is going to be 8.49. What about the 1000ths place? I have to look at the 2. What does the 2 tell me to do to the 5? Stays the same. So you should have 8.485. Now, I'm not going to ask you on every single question to do tens, hundreds, thousands. So you'll have to read directions, but you should know how to round to each of those numbers. Does that make sense? Okay. So let's do another Let's do another square root. Let's do the square root of 84. I'm going to do one more with you, and then I'm going to let you try it. So if I want to find the square root of 84, can you give me two numbers that multiply to 84?
And 2.
42 and 2? Okay. So 42 times 2, we can do that. There are other options, but we'll do the 42 times 2. I don't see any pairs, so I'm going to break down 42. What multiplies to 42? 6 and 7. Okay, still no pairs. Can I break down 7? No, because it's just 7 and 1, right? But I can break down 6 to 2 and 3. Now, before I look for pairs, what am I not looking at all? What am I going to ignore? The 42 and the 6, right? Because I've already broken them down. Do you see any pairs?
Yes.
What pair do you see, Tori? There's a 2. They don't have to be right next to each other, but they're still a pair of 2s. Are there any other pairs? No? Okay. So we know the 2 comes out. Do we have anything left over? A 7 and a 3. And what did we do with the leftovers? They stay inside, right? They go back on the inside. Any guesses on what I need to actually do with them? Because I can't just write 3 and 7 like that. How did we break them down? What did we technically do? What operation did we technically do to break that down? We divided, right? So what's the inverse of division if I'm going to put them back in? Multiplication. So we divided to break it down. And if I need to put them back into the square root because they're left over, I'm going to multiply them back together. Okay?
Just a hint for some of you that are, this is how my mind works. When you get this 42 twos, 6, 7, 2, 3, when I look up, I'll mess it up, which ones I'm crossing out. I'm organizational. So I actually dropped this number down. So this 2 would come down with the 6 and 7. And when I factored 6, the 7 would come down and the 2 would come down. I'd have them all in a row and then look for my pairs and put the other ones back in. So if you want to do that, like rewrite, all she would have done is drop one more number down. And when she got to here, drop 2 more numbers down. And then you would be done. And you could see all your numbers in a straight line. Does that make sense? So it kind of just looks a little more organized. If you don't, and this is good for you, go for it. It's just the way my mind works. So when I see all of them side by side, it's a lot easier and I don't forget them. It was just something I kind of put in place because I was forgetting them from time to time. So that helps you. Go ahead and do that as well.
Yep. So you can write it like that. Some people will also take all the numbers at the end and just write them out in order. So I see some 2s, I see a 3, and I see a 7. And then circle pairs like that. That's an option. Okay? So what I would like you to do, and if only one person in your group has a calculator, that's fine. I want you to tell me what the square root of 84 is to the 100th place. What is the square root of 84 to the 100th place? And if there's only one calculator, share with your group for now.
You did. Do it again. Square root.
All right, what was the square root of 84 to the 100th place? Who can help me with that? Square root of 84 to the 100th. Isaiah. 9.17. Did we get 9.17? Yeah? Did anyone not get that and not sure why? Awesome. Okay, so I would like you to try this one. So with your group, I would like you to find the square root of 96. So you're going to write it in simplest radical form. And I also want you to tell me what it is to the thousandths place. So what is the square root of 96 in radical form? And to the thousandths place. Absolutely. Can you give me two numbers that multiply to 96? 8 and 12? Okay. Did someone choose something else? Did anyone do, what'd you do, McKenna? 48 and 2? Did someone do 32 and 3? Okay. All of those will break down at the very end to the same thing. Okay, so let's break down 12. 12 breaks down to 4 and 2. No, it doesn't. How about 4 and 3? That's a 3. Hold on. Let me try again. 4 and 3. I don't know what I was doing in my head. 4 and 3, and then 4 breaks down to 2 and 2. I know, right? And then, hold on, I'm going to cross out the things I don't need anymore. And then 8 breaks down to 4 and 2 and 2 and 2. Okay. Do we see any pairs? I have a pair of 2s. Anything else? Another pair of 2s? Anything else? Huh? So you have an extra 3 and an extra 2. Right? So I'm going to multiply my pairs. 2 times 2 is 4. And then if I have an extra 3 and an extra 2, what do I do? What operation do I perform? Multiplication. So 3 times 2 is 6. Great. Now, how can we check our work again to make sure that's right? So I could do the square root of 96 to figure out what that is, and it's 9.79795. And then I can also do 4 times the square root of 6, and it should be the exact same thing, which it is. It's hard to see. So looking at that, and if I wanted you to round to the thousandths place, what did you get? 9.798. Good. Because it was 9.79795. Right? So I'm looking at the fourth one over. That 9 rounds the 7 up to an 8. Are we okay with that? Not too bad? Okay. We are going to have to stop because the bell's going to ring. We're going to continue a little bit more of this on Monday, probably right before the quiz.